So if the kinetic energy is greater than the potential energy, so that will be your H will be greater. So if the H will be greater, then this part will be some part and this plus 1, that means it will be greater than 1. Simple mathematics we can use. So E will be your greater than 1, that means it is your hyperbola. Similarly, if your kinetic energy is equal to the potential energy, then what will happen? It becomes H becomes 0. That means if H becomes 0, then this part will be 0. So almost 1 will be come. Right. So it will be equal to 1. That means parabola. And if kinetic energy is less than the potential energy, then similarly H becomes less than 1 and E becomes less than 1. That will be your elliptic path. It is pretty simple. Now, so till here, this is all about the basics. Now we are going to enter into the orbital. That means the orbit, that is your circular orbit or elliptical orbit. So basically now we are going to see the circular orbit. So from here we are going to see circular orbit. So basically the questions are coming from here, and the next topic which are coming in the next class, that is your elliptical orbit. Mostly the questions is arising from this topic. Till here the questions can come for 1 mark or sometimes 2 mark, but mostly 1 mark, because they have to ask one one mark question. So or also they can ask in MSQ. So different options they will give for true or false, and you have to select the answer. So they can give till here very nicely options, but now whatever we are going to do, that is purely based on the mathematics, and we have to derive some formulas, and we are using the formulas for solving the problems. So be patient and just stay with me. Let's start. So first topic, okay, let me start with this first topic, orbital. Okay, this orbital and circular are same. Circular energy. As I told you, key the capital mass, a small mass is moving, so it is having some kinetic energy and potential energy. So the sum of the kinetic energy and potential energy is the total energy. So basically it is the total energy, right? It is given by the ET. So right, ET is nothing but your total energy per unit mass. So what is your total energy? It is kinetic energy plus potential energy, right? Divided by mass. The mass of the small, that is small m I'm talking about. So what is kinetic energy? Half m b square, right? Minus g capital M small m divided by r, and whole divided by mass. So if you cancel the mass from here, so the ET will come v square by 2 minus gm by r. It is also a constant. So it is called the circular energy or orbital energy. Let's call this is equation number A. Let's start the numbering with the ABCD. Okay. Now draw one table, and this table you have to remember for any cost, because from this table every year 1 mark question is coming definitely and definitely, I'm saying. So first you write trajectory, then you write eccentricity E, then you write energy relation per unit mass, that is your energy, or that the above equation which I have derived, and that is then you write your orbital energy, that is your ET. Guys, 1 second, let me put my phone into the charge. 1 second. Okay, then now write ellipse first. Guys, please remember this table. Then you write parabola, then you write hyperbola, then you write circle. So for ellipse, if eccentricity is less than 1, for parabola eccentricity is equal to 1, for hyperbola eccentricity is greater than 1, and for circle eccentricity is equal to 0. What is energy relation? That means, okay, let me take first energy relation. If eccentricity is minus less than 0, that means the kinetic energy is greater than the potential energy. The kinetic energy is greater than the potential energy. That means this v square divided by 2 is greater than the gm by r, right? Of course, minus gm by r here. Again, if these are equal, then v square by 2 is equal to minus gm by r. And if it is greater than, then v square by 2 is greater than minus gm by r. Then one more case is there. For e is equal to 0, this case again come, v square by 2. Okay, sorry. Eccentricity will be less. For hyperbola, eccentricity will be, for this will be your less than minus g m by r. Now what will be the orbital energy? If the kinetic energy is less than this one, then it will be less than 0, right? From here equation, if this kinetic energy is less than this, then it will be your negative, that means less than 0. So ET will be less than 0. If it is equal, then ET will be equal to 0, and if it is greater than 0, then it will be greater than 0, and ET will be less than 0. See, what is this point? At this point, if the kinetic energy is equal to the potential energy, at this point the orbital energy is equal to 0. That means the body which is in the orbit, which is in the orbit, they are going to escape the particular orbit. Body is escaping. Or you can say start to, or ready to start to escape the orbit. So please you remember this table. It is very important table. Okay guys, then now let me start. Okay, let's do some wordings about this, right? A vehicle in orbit. So what do you understand by this? If you want to stay in the orbit, it means you're circular or elliptic, then your orbital energy must be negative, right? If you want to, I'm saying, if you want to stay in an elliptic orbit or circular orbit, then your eccentricity must be less than 1 or equal to 0, or your orbital energy must be less than 0. Or if you want to go to the in deep space, so you have to travel with the parabola eccentricity, whether it will be 1 or greater than 1. So your orbital energy will be equal to 0 or greater than 0. That means it will be positive. So right, a vehicle in orbit must have orbital energy or total mechanical energy, you can say, or you can say total energy negative. I'm writing with negative. I said you, if it is negative, total energy is negative, then you have to travel into the, you have to stay in the orbit. That will be your whether it is your elliptic orbit or circular orbit, it does not matter. Fine. Then now write again another one. This is your bullets 1, this is bullet 2. Therefore, for a vehicle intended to escape the earth and travel into the deep space, they must follow the parabolic or hyperbolic trajectory that means the total energy should be equal to or greater than greater than 0, that is ET must be 0, ET is greater than or equal to 0, that means the ET, that is the total energy, must be positive, and we can write also, and for this, see, for positive, how if you want to ET positive, then what will we do? We have to increase the kinetic energy compared to the potential energy. So for this, kinetic energy must be greater or equal to the potential energy. Right? So whatever I have said in the said, so we have written in the wordings so that you can understand. Now start. What is the velocity? As I said you, now see, write new topic, that is your orbital or circular velocity. See, I said you, if this is your capital mass, understand the figure. This is your capital mass and this is your small mass, suppose, and this is revolving around this capital mass in a circular orbit, I'm saying, right? Circular orbit, then it is having some velocity. Of course, I said you right. Acceleration, velocity, potential energy, kinetic energy. So acceleration, potential energy, kinetic energy, everything we have derived for any types of orbit. Okay. Only we have to only you have to put the eccentricity value 0 or 1 or less than 1, greater than 1, all that, so we can get. For this circular orbit we have some velocity at which this mass is revolving this capital mass, right? So that is our main agenda, to find this find this velocity of the circular orbit. So now write. So there is some derivation, please have patience and just let's derive this equation. Actually I don't want to skip the derivation, otherwise you will not understand the things very properly. So please write. E is equal to, that, okay, let me decrease the, E is equal to 1 plus 2 h square capital H divided by m k to the power 4, k to the power 4. So for a circular orbit, the eccentricity will be 0, right? So put eccentricity will be 0, this will be 0. So if you take another like this, so 1 plus 2 h square capital H divided by the m power 4. That means h is nothing but your minus m k power 4 divided by 2h square. This is your equation number 1, right? But h is nothing but your t minus 5, that is your kinetic energy, this is your potential energy. Can't write that, okay, write this, it's very okay, minus m k power 4 divided by 2h square is equal to 1 by 2 m velocity square minus g x small m capital M divided by r. Now see, I'm writing the velocity, but I'm finding the velocity of which velocity? Orbital velocity or circular velocity. So I'm writing this subscript O, that is the orbital, that is stand for orbital. Now if I if I take negative this side, so m power 4 divided by 2h square is equal to g capital M small m divided by r minus half naught square. Now you take outside 1 by 2 m v naught square is equal to g small m capital M. You bring this side and this bring this side, minus m ka power 4 2 h square. Now we know that, okay, now right, we know that equation of trajectory is r is equal to p divided by 1 plus e cos theta minus c, right? So if e is 0, then r is equal to p, right, which is your h square by k square. I have told already this value of p, right? Now substituting this in equation 2. Let's suppose this is your equation number 2, okay? This is your equation number 2. Substitute here. That's k square plus a square. It is reciprocal. So substitute here. Substituting in this. Substituting this equation. So you will get this half m p naught square k square m divided by r minus m k power 2 r. How it is coming? Because see, we can write gm is equal to k square, right? I said you already. Then this k square divided by h square is nothing but your r square. That is why I written r. One bar is getting cancelled. So now divide by m. So m is getting cancelled. So you know v naught square divided by 2 is equal to k square by r minus k square by 2r. Fine. That is equal to v naught square by 2 is equal to k square divided by 2r. 2 gone. Then v naught square is equal to k square by r, okay, which will be equal to the v naught root under k by r, that is equal to the gma divided by r. This is your orbital velocity, which is rotating about this. See, I've told you this is your orbital velocity, which I have drawn, which I have derived here. So you will only remember this formula. You don't need to mark up all this. If you want to go through the steps, you can go. Otherwise, you remember this. This is very important. Direct questions come from this. Find the circular or orbital velocity for a circular orbit. If the gravitational constant is given by this much, mass of the earth is given by this much, at height this much, then find this. So this r is nothing but your radius of the earth plus h is your height. Remember this. Now write one more topic, escape velocity. That means at which velocity one satellite or one thing or one rocket can escape one orbit to the another orbit, that is called your escape velocity, right? A space vehicle will escape if it has a parabolic or hyperbolic trajectory if it has, okay, consider parabolic trajectory that is E is equal to 1. I said you, if someone can escape the any orbit, then they has to travel with the parabolic or hyperbolic trajectory only, right? So now if E is equal to 1, then kinetic energy and potential energy will be equal to, then kinetic energy will be is equal to potential energy, right? We can write from here, from this table. If E is equal to 1, then kinetic energy potential energy equal to 1. I think you know, you can write from here also. If E is equal to 1, then kinetic energy and potential energy will be equal. That means what will be your kinetic energy? Half m v square is equal to g capital M small m divided by r. Right. So this E velocity, we are finding this escape velocity, so we are writing this E. Okay, so we are mass is gone, then it is nothing but your v is nothing but your 2 times of gme divided by r. This is your escape velocity. This is equation number C. Now see, this escape velocity is root under 2 into root under gme by r. This gme divided by r is nothing but your orbital velocity, right? VO. So orbital velocity you can see here, gme by r. So VA, that is your escape velocity, is nothing but your root under 2 times of V naught. So please don't forget this root. Don't forget this root, because in my exam I have forgotten this root and just I lose 2 marks.